Hello everyone and welcome to this presentation titled The Effect of Oil Quality, Phytase and Vitamin E Supplementation on the Growth Performance, Nutrient Utilization and the Relative Fat and Liver Weight of 21-day-old broiler chickens. Now, to start with, oils are very important in poultry diets for a number of reasons. Firstly, it's an easy way of raising the energy level of feed. It's a source of essential fatty acids. It acts as a vehicle for vitamins. It reduces the dustiness of feed and improves palatability. Now, most vegetable oils used in poultry diets are very rich in polyunsaturated fatty acids. And because they have lots of double bonds, when they are exposed to reactive oxygen species or free radicals, they tend to be prone to oxidative deterioration. And lipid oxidation itself is a free radical chain reaction that occurs in three main steps, which are the initiation, the propagation, and the termination. Initiation leads to the formation of primary products such as hydroperoxides. Propagation leads to the formation of secondary products such as aldehydes and ketones, while termination leads to the formation of tertiary products, which usually is some sort of non-radical product or indigestible polymer. Now, there are various factors that influence the rate of lipid oxidation, and they include heat, light, and the presence of pro-oxidant metals like copper and iron. Now, as these various products of oxidation are formed, they react with more lipids and proteins, thereby damaging them and making it harder for the animals to utilize their nutrients. And when such oxidized diets are fed to broilers, it can induce oxidative stress, reduce the efficiency of feed, and ultimately affect the animal welfare. So the next question is, how do we correct or prevent this? And usually the answer lies in some sort of antioxidant, one of which is vitamin E, which is well known for its ability to protect against oxidative damage. Now, vitamin E itself is a common name for a group of compounds known as tocopherols and tocotrienols. Now, both group of compounds are 4 isoforms each, which are the alpha, the beta, the delta, and the gamma isoforms. Now, interestingly, most studies in poultry nutrition that have utilized vitamin E are focused heavily on just one form of vitamin E, known as alpha tocopherol acetate, which is actually a synthetic form of vitamin E. So a lot is yet to be understood regarding the other naturally occurring isoforms of vitamin E, especially when they are mixed together. Another common feed additive used in poultry diets is phytase, which is an enzyme that liberates phosphorus from phytic acid. Now, phytic acid is a storage form of phosphorus in plants, and apart from being the storage form of phosphorus, it also binds to metals, to proteins, and to fat to form a complex. Now, unfortunately, animals are unable to utilize the phosphorus or any other nutrient when it is bound in phytic acid because they do not have the enzyme required to liberate this nutrient, and this enzyme is phytase. So when phytase is supplemented, it releases not just the phosphorus but also the minerals, the proteins, and the fat that are previously bound in the phytic acid complex. So consequently, that means the supply of phytase doesn't just affect the digestibility or utilization of phosphorus, but can also affect that of other nutrients as well. So for the background I have given so far, a few questions pop up naturally. For instance, how do mixed tocopherols, mainly composed of gamma tocopherols, affect broilers? And specifically, from a practical standpoint, how does phytase, vitamin E, and oils of different peroxidation levels affect the broiler performance, the nutrient utilization, and the relative weight of the liver and adipose tissues? Now, these were the questions we sought to answer with this study. And we hypothesized that the dietary supply of oxidized oils will depress growth performance and nutrient utilization, while vitamin E and phytase supplementation will help ameliorate these effects. So as an objective, we sought to evaluate the effect of oil quality, phytase, and vitamin E supplementation on the growth performance, the nutrient utilization, bone mineralization, and the relative weight of the fat and liver of 21-day-old broiler chickens fed a marginally phosphorus deficient diet. So, to accomplish this, we obtained 374 male byproduct called breeder chicks from a commercial hatchery, and using a completely randomized design, on day 7, the birds were randomly assigned to 9 dietary treatments containing 7 replicates and 6 birds per replicate. And this was done using a 2x2x2 plus 1 factorial arrangement of treatments. From day 0 to 7, the birds were fed a standard corn soybean meal diet containing fresh oil and adequate levels of energy and non-phytate phosphorus for birds of this age. And from day 7, they were placed on the experimental diet, where they remained on for the next 14 days until the study was terminated on day 21. Now here's the dietary treatment layout, and here we see the three factors: the oil quality, vitamin E supplementation, and phytase supplementation. Now we have two levels of oil quality, which were fresh oil or oxidized oil, and the measure of oil quality for this study was the peroxide value, which was determined to be 4 milliequivalents of oxygen per kilogram for the fresh soy oil, while the oxidized soy oil had a peroxide value of 109 milliequivalents of oxygen per kilogram. Now the oil inclusion level was 3%. Now the oxidized oil were generated by placing fresh oil in the oven at 95 degrees for 84 hours. Now under each oil quality level, we had two supplemental vitamin E levels. We had either no supplemental vitamin E or supplemental vitamin E at 150 parts per million. Now the supplemental vitamin E in this case is in addition to the basal level of vitamin E. So this is even the groups without supplemental vitamin E still at some basal level of vitamin E, and the vitamin E used in this study was a mixed tocopherol containing all 4 isoforms of the tocopherol. Now under each supplemental vitamin E levels, we had two levels of supplemental phytase. We had either no phytase or supplemental phytase at 1000 FTU per kilogram. Now the first treatment here is a positive control containing no phytase, no vitamin E, and made with fresh oil, while the second treatment here is a negative control. It also contains no phytase, no vitamin E, and fresh oil, and the only difference between the two is that the positive control had adequate level of non-phytate phosphorus, which was set at 4.5 grams per kilogram, while the negative control contained 3.1 gram per kilogram of non-phytate phosphorus, which was considered to be marginally deficient. Now all 8 diets were based on this marginally deficient level of NPP, while only the positive control had the adequate levels. Now the birds and feed were weighed on days 7, 14, and 21 to calculate the body weight gain, the feed intake, and the feed efficiency. The excreted samples were collected on days 19 and 20, and on day 21, 1 bird per cage, close to the average body weight, was euthanized to collect the liver, the tibia, the abdominal fat, and the subcutaneous fat. The relative weights of the liver and the fat were calculated, and from the diet and excretum, we determined the dry matter, the gross energy, the crude fat, the calcium, phosphorus, nitrogen, and the titanium, which was the digestibility marker for the study. Also, the bone breaking strength and the bone ash were determined from the collected bone. Okay, moving on to the statistical analysis. The experimental unit for the performance data was the pen, while the experimental unit for all of the data was 1 bird per pen. The values greater than 3 standard deviation from the mean were removed prior to analysis and treated as outliers. And all of the data was subjected to the GLM procedure of SAS that is appropriate for a factorial arrangement of treatments. The effect of the dietary non-phytate phosphorus level was determined by comparing the positive control to the negative control using the contrast function of SAS. And the level of significance was set at p less than 0.05, and the differences among the means were identified using Tukey's honest significant difference. Okay, moving away from the materials and methods, here is the first result, and here we have the main effect of phytase on feed efficiency, and this was examined over 2 time periods, over days 7 to 14 and days 7 to 21. And for both time periods, phytase supplementation actually improved the feed efficiency with a 1.9% improvement over day 7 to 14 and a 1.2% improvement over day 7 to 21. Now, this improvement is likely due to the reduction in the anti-nutritional effect of phytic acid, which occurs when it is hydrolyzed by phytase. Also, the greater availability of previously unavailable nutrients is believed to have played a role in improving the feed efficiency. Now, here's a chart showing the main effect of vitamin E on the body weight gain. And as expected, vitamin E supplementation actually improved the body weight gain by 3.6%. And this beneficial effect is believed to be due to the ability of vitamin E to protect nutrients from oxidative degradation. So this consequently reduces the oxidative load within the gut and possibly improved the efficiency of nutrient absorption. Now here's a chart showing the relative weights of the fat and liver across all the treatments. And although there were no differences in the relative weights of the abdominal and subcutaneous fats, there was an increase in the relative liver weight when the birds received oxidized oil compared to when they received fresh oil. Now, the relative liver weight is also known as the hepatosomatic index, and a higher value of this index usually signifies increased toxicity. And this was expected because the various oxidation products can be considered toxic by the body. And so an increase in the liver size is possibly due to increased enzyme synthesis and hepatocyte proliferation, which is all done in an attempt to ameliorate the toxicity. Now, here's a chart showing the main effect of phytase on the bone breaking strength and the bone ash. And in both cases, there was an improvement when phytase was supplemented. And this was expected because as phytase hydrolyzes phytic acid, more phosphorus is released alongside other minerals such as calcium, which are then incorporated into the bones, which then results in the improvement in the bone breaking strength and the ash content. So here's a table showing the total tract utilization of dry matter and nutrients, and as expected, phytase supplementation actually improved the calcium utilization. And this was expected because, among other things, when phytic acid is hydrolyzed by phytase, the previously bound calcium is released to the gut of the birds and is now available for the birds to utilize. But surprisingly, phytase supplementation actually negatively affected the crude fat utilization, and this negative effect carried over to a two-way interaction where oxidized birds that received oxidized oil but no phytase actually performed better in terms of the crude fat utilization compared to those that received fresh oil with phytase. Now, this was completely unexpected and contradicted our hypothesis because oxidized oils have been linked to a negative effect on the crude fat utilization, while phytase supplementation have been linked to a positive effect. So a positive effect by oxidized oil and a negative effect by phytase was completely unexpected. So this result is somewhat difficult to explain, and further research will be required to fully understand the underlying mechanism that may be driving this effect. Here is a table showing the total tract utilization of energy, upright metabolizable energy, and the upright metabolizable energy corrected for nitrogen. Now, a two-way interaction was observed between phytase and oil quality, and for birds that receive oxidized oil with phytase, there was an improvement in both the AME and AMEN compared to birds that received either oxidized or fresh oil, but no phytase. Now, while it was surprising that oxidized oil actually improved the AME and AMEN, it was expected that phytase will produce this effect because previous studies have reported a positive effect of phytase on AME and AMEN, and this is believed to be due to small but additive improvements in the utilization of carbohydrates, of proteins, and of fat. So, in conclusion, phytase supplementation improved the feed efficiency, calcium utilization, bone breaking strength, tibia ash, upright metabolizable energy, and the upright metabolizable energy corrected for nitrogen, regardless of oil quality or vitamin E supplementation. Furthermore, dietary supplementation of mixed tocopherols, mainly composed of gamma tocopherols, significantly improved the body weight gain in 14-day-old broilers fed a marginally phosphorus deficient diet. And finally, when feeding oxidized oils, phytase supplementation improved the upright metabolizable energy and the upright metabolizable energy corrector for nitrogen, but reduces crude fat utilization. Here are my references. Thank you for listening. I'll take your questions now.